So those are the numbers we can pull out. So when you divide here, you don't want to divide out a composite number, because these numbers that we're going to divide out are going to be the prime factorization. So you only want to divide out numbers like 2 and 3 and 5 and 7 and 11, 13, 17, and 19. Obviously, dividing by 2, if they give you an even number, is a great place to start, because that doesn't take the numbers down very quickly, but we know 2 is always going to go in. So they start off here, and they do 476 divided by 2. When I do 476 divided by 2, I get 238. Then I divide by 2 again. Remember, I'm only dividing out prime numbers. Right? So you're never going to see me write a 4 here or a 9, because those are composite. 238 divided by 2 is 119. Now, no longer is this even, so I can't keep taking out 2, but I can take out 7. 119 divided by 7 is 17. When I take 17 out, 17 divided by 17 is 1. Once you get to 1, that's how you know you're done. These numbers out here, the 2, the 7, and the 17, that's my prime factorization. And you write the answer the same way we did with the factor trees. It does not matter which you do, either one yields the correct answer. All right, here's 275, all right, using the division technique. So obviously, since it ends in 5, a good place to start would be to divide out 5, since 5 is a prime number. So I divide out 5. 275 divided by 5 is 55. Then I divide out 5 again. 55 divided by 5 is 11. All right, then I take 11 and chop out 11. 11 divided by 11 is 1. This is how I know I'm done. These numbers that I divided out here, that is my prime factorization. 5 times 5 times 11. Or if you want to write it with exponents, 5 squared times 11. All right, so let's practice these things here. All right, number 1, we're supposed to tell whether the number is prime or composite. So we've got 39. Well, we know 39 is 1 times 39. That's what makes it prime. We just have to find something else to prove it's composite, and if we don't, it's prime. So 39 divided by 2, that doesn't work, but 39 divided by 3, well, that's a dead giveaway right there. 39 divided by 3 is 13. Since something else goes in, that makes it automatically composite. Don't have to test anything else. We're just proving prime or composite. All right, number 2, they're asking us to write the prime factorization of the number, and they're asking us to do the same thing in number 3. Now, you can employ either technique that works for you here. But what you're going to see me do most often is the prime factorization via factor trees. So I've got the number 90 here. Remember, when I do the factor trees, the branching diagram, each subsequent level is the product of what's directly above it. And you get to stop when you have prime numbers. So 90 makes 9 and 10. Now, neither of those happen to be prime numbers, so both are going to have to continue being branched out. 9, well, 9 is 3 times 3. 3 is a prime number. The only way to make 3 is 1 times 3. So those are both prime. And then with 10, the only way to make 10 is 5 and 2. 5 and 2, well, those are both prime numbers as well. And since now all the branches are primed out, that's going to be my prime factorization. Now, you don't want to stop there, though. You actually need to write the prime factorization. So you can write 2 times 3 times 3 times 5. Or you can write this with exponents if you want. And that would be 2 times 3 squared times 5. All right, 325. Lots of options again here, but I know 25 goes into it. Here's the thing. You can pick small numbers every time if you want, like 2s and 5s. But the problem is it's going to be a longer tree diagram because it's going to take you longer to factor out the bigger numbers. So if you pick bigger numbers to work with, or numbers at least that are numbers that are closer together, all right, like 25 and 13 are closer together than 5 and 65. All right, if you pick those numbers that are closer together, that's probably going to lead to a shorter tree diagram. So 25 and 13 isn't bad because 13 is a prime number, so I don't have to do anything else with that. 25 is not, so 25 has to get broken down. 25 is 5 and 5. Right, and so that's my solution there. 5 times 13. Or if you want to write this with exponents, 5 squared times 13.